Hey there guys, how's it going? This is Mike coming back at you with another video on Intro to Algebra. In the previous video, we talked about least common denominators of rational expressions and how we find those things. In this video, we're going to talk about adding and subtracting rational expressions. It works in the exact same way as how we added and subtracted just basic fractions. We're going to use the same steps, but we're just using those same steps with some different stuff being thrown in there. So when we added or subtracted just basic fractions, we'd use the following steps. First, we'd find the LCD of the two fractions. Then we'd see, okay, what do I have to multiply each fraction by on the top and bottom to reach the LCD? Or I should say, so that you got a fraction where the new denominator was your LCD. And then you just added or subtracted the fractions together now that you had the same denominator. And then you simplified as much as you could. So we're going to do the exact same process. We're going to find the LCD. We're going to figure out what we need to multiply on the top and bottom by for each rational expression so we get the LCD, and then we're going to add or subtract the numerators and simplify as much as possible. We're going to do that same process, but now we have variables being thrown in, and factors like x, or x minus 3, or something like that, 2x minus 1, or something like that. So let's go through this process with some sample problems. So first, 10 divided by 3x cubed minus 7 divided by 18x. We're going to subtract these two rational expressions. So first thing we have to do, find the LCD. From our last video, we talked about finding the LCD. So we write 3x cubed is 3 times x times x times x. 18x, we can write 18 as 2 times 3 times 3, and then multiplied by that x. So now we find the LCD here. Here we have 1, 2, here we have no 2's, so that means we'll have 1, 2. Here I have 2 3's, here I have 1, 3. That's going to give me 2 3's. Here I have 1x. Here I have 3 x's, so that means 3 x's, and that's going to give me 18x cubed. So 18x cubed, that is my LCD. Now, I have to look at each of these rational expressions and say, okay, I want to go from 3x cubed to 18x cubed. What do I have to multiply to go from this guy to this guy? So, if you just do some quick mental math, you would find that you multiply by 6, or if you did 18x cubed divided by the 3x cubed, you'll get 6 as well. So I multiply the bottom by 6 to get here. So I have to multiply the top by 6 as well, and 10 times 6 is 60. I'm going to do the same thing with the 7 over 18x. What do I have to multiply 18x by to give me 18x cubed? Well, if you, again, do some mental math, or if you do 18x cubed divided by 18x, you'll get x squared. So I have to multiply the bottom by x squared to get me here. So I multiply the top by x squared as well. So now, I just subtract these two rational expressions. So I have 60 over 18x cubed minus 7x squared over 18x cubed. And now the denominators are the same. so we can just subtract the numerators. So I have 60 minus 7x squared, all divided by 18x cubed. So again, just focusing on the steps that we did, we found the LCD just like we did in our previous video. Then, once we found that LCD, we figured out what we had to multiply by to get an equivalent rational expression with the denominator now being the LCD. We've been doing this throughout the whole course. We've been multiplying the top and bottom of a fraction by something to get what we want. And now just basic properties of adding and subtracting fractions or rational expressions. We subtracted the numerators here. So we'll do some other ones. Uh, 4x divided by x squared minus 1 plus 3 divided by x minus 1. So again, we're going to start off. Find the LCD. Well, x squared minus 1, if we factor, is x plus 1 times x minus 1. X minus 1 on its own is just x minus 1. We can't break that down. We can't factor that any further. So now, let's take whatever is the larger number of the factors that are appearing in either of these denominators here. So here I have one factor of x plus 1. Here I have no factors of x plus 1. So that means my LCD will have one factor of x plus 1. Here I have one factor of x minus 1. Here I have one factor of x minus 1. So my LCD will contain one factor of x minus 1. So this is your LCD. And if you were to multiply it out, you would get just x squared minus 1, which is already what one of our denominators is. So, if I want to take 4x divided by x squared minus 1 and change it to be something where the bottom is x squared minus 1, well, I'm not changing that bottom, which means you don't change the top. So the top is just going to remain the same as well. We don't have to mess with this first rational expression. The second rational expression, though, we do have to do some messing around with. I want to go from an x minus 1 to an x squared minus 1. Or, as we see here, x plus 1 times x minus 1. So I have to multiply the bottom by a factor of x plus 1 to get here, which means I have to do the same thing to the top. So that's going to give me 3 times x plus 1, or 3x plus 3 divided by x squared minus 1. And now we can add these two expressions. 4x divided by x squared minus 1 plus 3x plus 3 divided by x squared minus 1. We add the numerators, and we see we have a 4x plus a 3x. That gives me 7x, and then we're going to add 3. So we have 7x plus 3 divided by x squared minus 1. I'll let you try the next one on your own. We'll go down to the third one. A bit trickier, but that's okay. Again, start off by finding the LCD. A squared plus 3a minus 4, a squared plus 7a plus 12. So if we factor each of these things, we get a plus 4 and a minus 1 for the first one, and we get a plus 4 and a plus 3. I'll make that look more like a 7 there. So now, for the LCD, this guy has a factor of a plus 4, and this guy also has a factor of a plus 4. So the LCD will have one factor of a plus 4. This guy has a factor of a minus 1. This guy doesn't. So again, using the greater number of factors, the LCD has to have an a minus 1. And by the same reasoning, the LCD has to have a factor of a plus 3. Now, you could multiply this out, but we're not going to. We're just going to leave it like this. It'll be a lot nicer visually. So, a divided by a squared plus 3a minus 4, which, as we saw here, was a plus 4 times a minus 1, equals, this has to be equal now to something where the bottom is a plus 4 times a minus 1 times a plus 3. So how do we do that? What do I have to multiply this thing by to get this? Well, I have to multiply by an a plus 3. So that's exactly what we're going to do to the top as well. And if you multiply that, you get a squared plus 3a times the a plus 4 times the a minus 1 times the a plus 3. Now, same kind of thing with the second rational expression here. We have the 4a divided by, and now the a squared plus 7a plus 12 was the a plus 4 times the a plus 3, and this has to equal something divided by a plus 4 times a minus 1 times a plus 3. And what do I have to multiply this guy by to get this? I have to multiply by the a minus 1. So I'm going to do the same thing there. 4a times a minus 1. This is 4a squared minus 4a. A plus 4, a minus 1, a plus 3. So, I have these two rational expressions, which are the same as these things. So, I'm just going to add these things. A squared plus 3a divided by a plus 4 times a minus 1 times a plus 3 plus the 4a squared minus 4a divided by a plus 4, a minus 1, a plus 3, and this will give me, combining like terms in the numerators, I have a squared plus 4a squared, which gives me 5a squared, and then a plus 3a minus 4a to give me minus 1a or minus a. All divided by a plus 4 times a minus 1 times a plus 3. Now we can factor this numerator. I can pull a common factor of a out of each of those terms. And yes, that perhaps looks a bit nicer visually, but it doesn't really help us cancel anything out. We can't cancel out any common factors here on the top and bottom. Everything just sort of remains as it is. So going to the back of the page, I have a few more here. These are all on the same level of difficulty or easier than the ones that we just did. So I will let you try these ones on your own. You have 11 divided by 2r cubed minus 5 over 9r. You have 4x divided by x squared plus 8x plus 16 minus 7 divided by x plus 4. And then you have 3x divided by x squared minus 1 minus 4x divided by x squared plus 5x plus 4. Again, you're going to use the same process. You're going to find the LCD of the two rational expressions that you're given. You're going to figure out what do you need to multiply each of the denominators by to get the LCD. Wherever you have to multiply the bottom by, you multiply the top by as well. And then you just add or subtract those rational expressions now that the denominators are the same. So guys, if you have any questions, feel free to reach out to me, talk to me after class, stop into my office hours, send me an email, send up the mic signal, carrier pigeon, telegram, signs flying off the backs of planes, whatever you have to do. Until the next video, take it easy, guys.